Welcome to part 2, not so simple fractions. So these are mixed numbers, and I'm going to go over how to add and subtract, multiply and divide mixed numbers. So let's start with this one right here. My recommendation is always convert mixed numbers to improper fractions. You don't have to, but 90% of the time it'll make the process much simpler and a lot less work. So let's go ahead and we'll pick a color here. We're going to go ahead and convert these. The whole number times the denominator plus the numerator. So 1 times 8 plus 1 is 9. So we have 9 eighths times 2 times 4 is 8 plus 3 is 11. Now I look at my diagonals, there's nothing I can do. Just multiply straight across. We have 99 and 8 and 8 16, so this is 32. Now I know if this was a 33 that 3 of those would fit, so I'm just going to go ahead and put 3. 3 times 33 would be 99, but I'm doing 1 less 3 times, so 96, which would mean I would have 3 left over. And if I'm not sure, I can do it again. 3 times 32 is 96 plus 3 is 99. And then we keep the same denominator. Okay, now, we have 2 negative mixed numbers. Now, what do I know about multiplying a negative times a negative? Well, it's a negative times a negative is a positive. So really, I don't even need to worry about these negative symbols. I'm just going to act as though they're not there because I know that this is a number. This is a number times another number. This is a negative number times a negative number. I'm going to have a positive answer. So I'm just going to go ahead and convert these right now. 2 times 3 is 6 plus 1 is 7. Keep the same denominator. Times 2 times 3 is 6 plus 1 is 7. Keep the same denominator. I'm looking at my diagonals. I cannot simplify. I'm just going to multiply straight across. 7 times 7 is 49. And 2 times 3 is 6. Let's go ahead and convert it. Let's see. I know this is going to be less than 10 because 6 times 10 would be 60. 6 times 8 is 48. So 8. And I have 1 left over. And that's it. And if I'm not sure, I can go ahead and convert this back. Let's see. 6 times 8 is 48 plus 1 is 49. And then I keep the same denominator. So you can see we went from an improper to a mixed number back to an improper. Okay. Now we have a negative number times a positive number. Well, I know that a negative times a positive is a negative. Now, one thing I do to make sure I don't forget this is I make what's called an answer box. This is where my answer is going to go. And I go ahead and I put a negative sign in there because my answer will be negative because I have a negative times a positive, and I know that's a negative. So rather than try to remember that or try to deal with this negative sign, I just make my answer box. I know whatever I end up with is going to go in here, and I'll never forget my negative symbol because I already added it to my answer box. So the first thing we want to do is let's make sure we have a fraction times a fraction. Well, 2 is the same as 2 over 1 times, and now we'll convert this to an improper. 1 times 4 is 4 plus 3 is 7, and we keep the same denominator. Now I notice my 2 and my 4, I can cross simplify here, and I'm going to go ahead and do that. How many times does 2 go into 2? Well, once. How many times does 2 go into 4? Twice. And then we go ahead and multiply straight across. 1 times 7 is 7. 1 times 2 is 2. And I'm going to go ahead and convert this back to a mixed number. 2 goes into 7 3 times, which is 6, so I have 1 left over. And so my answer is 3.5, but it's not. It's negative 3.5. And I didn't forget my negative because I already had it there. Okay? Last one. Oh, they're not mixed numbers. But this negative, the negative isn't here, it's up here. Well, let's think about it. We know this is a positive number. We know this, we're not sure, but we have a negative 3 over 8. Well, this is the same as division. Negative 3 divided by 8. A negative divided by a positive is a negative, so this whole thing is a negative. So I have a positive times a negative. So I'm going to go ahead and make my answer box again. And I'm going to go ahead and put a negative symbol in there so I don't forget. And then I'm not going to worry about the negative symbol. Now, one other thing. If this 8 were also negative, what's a negative divided by a negative? Well, positive. That would make this actually positive 3/8 if it were like this. And then we would have a positive times another positive. So my answer would be positive. I wouldn't need the answer block. My answer would be positive, but it's not. It is a negative divided by a positive, which makes this a negative. Therefore, this is a positive times a negative. My answer will be negative. So now let's go ahead and do it. We don't need to convert anything, so let's just do it right here. I'm looking at my diagonals. I got a 3 and a 3. Well, 3 goes into itself once, 3 goes into itself once. I look at these diagonals. I know 2 goes into 8. Okay, so 2 goes into itself once. It goes into 8 4 times. And now we just multiply across. 1 times 1 is 1. 1 times 4 is 4. So 2/3 times negative 3/8 equals negative 1/4. Okay, so 1 times 8 is 8, plus 1 is 9. Keep the same denominator. Divided by 2 times 4 is 8, plus 3 is 11. Keep the same denominator. I'm running out of room, but we're going to go ahead and we're going to keep change flip. So we have 9/8 times, we've changed it to times, to multiplication, and we're going to go ahead and flip this. Instead of 11 over 4, it's going to be 4 over 11. Now, one thing I noticed right away is my 9 and 11 I can't do anything with, but my 4 and my 8 I can. So 4 goes into itself once and into 8 2 times. So now 1 times 9 is 9, and 2 times 11 is 22. And I know it's already simplified because it's simplified here and simplified there. So this is my answer. Well, I know a negative divided by a negative is a positive, so I don't need to worry about my negative symbols because eventually my answer will be positive. So let's go ahead and convert these. 2 times 3, 6, plus 1 is 7. I'm going to try to make it a little smaller. Keep the same denominator. And divided by 2 times 3 is 6, plus 1 is 7 again. That's a 7. And keep the same denominator. Now we're going to go ahead and keep. We're going to change and flip. Look what that did. Sorry about the 7. But our 7s are on the diagonal, so these can both go into themselves one time. It's already simplified. 1 times 2 is 2. 1 times 3 is 3. And so my answer is 2/3. Oh, we got a negative divided by a positive, so my answer is going to be a negative. So I'm going to go ahead and make my answer box so I don't forget that negative. Okay. I'm going to convert this to a fraction divided by 1 times 4 is 4 plus 3 is 7. Keep the same denominator. Now we're going to keep, change, and flip it. And I don't see anything I can do on my diagonal, so we're just going to multiply straight across. 2 times 4 is 8. And 7. 8 over 7, that is an improper. I'm going to go ahead and convert it back to a mixed number. 7 goes into 8 one time with 1 left over, and we keep the same denominator. And our answer will go in here, so we keep it negative. 1 and 1/7 is our answer. Negative 1 and 1/7. We talked about this before. This is a positive divided by a negative, so our answer will be negative. So let's go ahead and make our little answer box with our negative symbol. And they're already proper fractions, so we don't have to convert anything. So let's just go ahead and keep, change, and flip. My diagonals can't do anything. It's going to multiply straight across. 2 times 8, 16. 3 times 3 is 9. That's an improper. Let's go ahead and convert it back. 2 9s is 18, so 1 9, and I have 7 left over. Keep the same denominator. So my answer is negative 1 and 7/9. Okay, next we're going to go into some addition. First thing, convert them into an improper fraction. 1 times 8 is 8 plus 1 is 9 over 8 plus 2 times 4 is 8 plus 3 is 11 over 4. Now, with addition and subtraction, we have to have a common denominator. These are not common, they're not the same. So the next question is, will the little number fit into the big number evenly? And in this case, it will. I can simply multiply this 4 by a 2, and that will give me an 8. And if I do the bottom by 2, I'm going to go ahead and do the top by 2. Again, because we're multiplying by 1 to keep the same value as 11 over 4, but we want it to look differently. So let's go ahead. I think I'm going to use yellow. So 9/8 stays the same. We don't have to touch it. Plus 2 times 11 is 22 over 8. 22 plus 9 is 31. 8 plus 8, no, we keep them the same, remember. And that's our answer. As an improper, let's go ahead and convert it to a mixed number. How many 8s fit into 31? 5 times 8 is 40. 4 times 8 is 32, so this is going to be 3. 3 times 8 is 24, so I have 7 left over, and I keep the same denominator. And so 1 1/8 plus 2 3/4 equals 3 7/8. Here's another one. We have a negatives. In this case, if I have a negative and a negative, remember when we add and subtract integers, if we have a negative 3 plus a negative 5, what are we doing to these numbers? These are price tags. These are items you threw in your shopping cart. This is a price tag and that is a price tag. We're simply adding them together. What I'm going to do is I'm going to go ahead and make my little box for my answer again. And I'm going to put the negative symbol because there's no way that I can put this item that costs $2 and some change plus this item that costs $3.50. There's no way I can put both these in the cart, go to the checkout, and they're going to hand me money. So they're definitely, this is a negative number. So let's go ahead and convert these. 2 times 3 is 6 plus 1 is 7 thirds plus 2 times 3 is 6 plus 1 is 7 over 2. So we need like common denominators in order to add and subtract fractions. These are not common. Will the little number fit into the big number evenly? It will not. So in this case, what we'll do is we simply multiply them together. So this one will be multiplied by 2, and this one will be multiplied by 3. And again, what we do at the bottom, we do at the top. And then we make our new fractions. 2 times 7 is 14. 2 times 3 is 6. 3 times 7 is 21. 2 times 3 is 6 again. It better be the same as this one because that's the whole purpose of doing it, is so we get a common denominator. And we leave the denominator the same. And now we have 14 plus 21, which is 35. Well, how many 6s go into 35? 6 times 6 would be 36. So 5 6s give me 30. That gives me 5 left over. And we keep the same denominator. Now at this point we might say, hey, there's our answer. But we remembered to make this box so we wouldn't forget this negative symbol. And now when we plug it in, the real answer is negative 5 and 5/6. Let's change that to 2 over 1. And this is a negative 2 plus, and we're going to go ahead and convert this. 1 times 4 plus 3 is 7. So 7 goes on top. 4 stays the same. Now, we're adding these fractions, but we have uncommon denominators or unlike denominators. So, will the small number fit into the big number evenly? Well, yes. What can we do to this 1 to make it a 4? We're going to go ahead and multiply this side by 4, including the top. And we don't have to do anything to this side because it already has a 4. So our new numbers are going to be 4 times negative 2, which is negative 8, over 4, plus 7 over 4 equals something over 4. And now we just go back to adding and subtracting positive and negative integers. Okay? I have $7, that's my positive. I'm spending 8. Do I have enough money? I don't. How short am I? I'm negative 1 short. Okay? Now I can change this to be negative 1/4 is my answer. So when you get to this point, you're simply adding a negative 8 to a positive 7. And if you think of money, This -8 is a price tag. This is an item I put in my shopping cart. This positive number is cash on me, whether it's money in my wallet, change in my pocket. But I have $7 and I need to spend, or I want to spend $8. I'm $1 short. So that's how we got a negative number out of that. And it makes sense. If you look up here and we were to convert this to money, let's change it to money. -2 would be -$2. That's a price tag. We want to buy something that costs $2. Well, how much do we have? We have $1 and 3/4 of a dollar. Well, 3/4 is 75 cents. So we have $1 and 75 cents. Well, if we have $1 and 75 cents and we want to buy something that's $2, we're actually a quarter short. There's a quarter, and that's a short, and that is the same as this -quarter, -25 cents. All right, last one. Well, they're already fractions. We don't have like denominators, so let's make them like denominators. Will the small number fit into the big number evenly? No. So we're going to go ahead and multiply them to each other. This 3 is going to be multiplied to this 8. This 8 is going to be multiplied to this 3. What do we do to the bottom? We do the top. And then we go ahead and make our new fractions that are the same value. 3 times 8 is 24. Our denominators are going to be 24. Two times 8 is 16. 3 times 3, 3 times -3 is -9. So now we have $16. We want to buy something that costs $9, and that's a positive 7 because we had more money than what we wanted to buy. So 7/24. So next we're going to do some subtraction problems. So let's go ahead and convert. 1 times 8 is 8, plus 1 is 9. Keep the same denominator. Subtract. 2 times 4 is 8, plus 3 is 11. Keep the same denominator. All right. Well, in order to add and subtract, we need to have the same denominator. And again, let's do orange. They're not the same, so does the small number fit into the large number evenly? In this case it does, so we can just work on this side instead of working on both of them. I know that multiplying by 2 will make this an 8. So our new numbers are 9/8 minus 2 times 11 is 22. And our answer is going to be something over 8. So let's look at this. You might say, well, these are both positive numbers, but they're not, because this is a positive number, but we're taking away this. So really, this is really -22. We could say we're adding a -22. We can say 4 minus 2, or we can say 4 plus a -2. It's the same thing. And so in this case, we're actually subtracting 22, or adding a -22. So if I have $9, do I have enough to buy this item? Well, I don't have enough, and so I need to say I have $9 and I want to spend $22. I'm actually $13 short. Okay. Now this is an improper. How many 8's go into 13? And I can write it out as -1 5/8 is the correct way to write that. And there's my answer. Next one, we need to convert these. So let's go ahead and do the conversion really fast. 2 times 3 is 6, plus 1, 7. Keep the same denominator. And we know this is a negative. And we have minus and negative 3.5. Well, minus and negative I know is the same as plus. So I can just say plus 2 3s plus 1 is 7. Same denominator. Okay. So really I have negative 7/3 plus 7 over 2. So in order for me to add these, I need to have a common denominator. Now, these aren't common, and the 2 does not go into 3 evenly, so we will have to multiply them to each other. So this 3 will be multiplied by this 2, and this 2 will be multiplied by this 3. And we'll do the same to the tops. 2 times 7 is 14. And we know this is a negative, so I'm just going to make that a negative 14. 2 times 3 is 6. We're adding now because this was a double negative, and we know the denominators are going to be 6's. And so 3 times 7 is 21. And now it's pretty simple. This is a negative 14. That's a price tag on an item that you want. And this is $21. We have $21 in our pocket. So if we wanted to buy that item that costs $14, do we have enough? Sure. We have actually $7 more than the item costs. Now we're going to pretend we're in Oregon and there's no tax. But this is an improper fraction. We can convert it. So 7 over 6 is how many 6's go into 7? Well, 1 with 1 left over. And that is our answer. And it's a positive answer because this number is bigger than this number. This positive number is bigger than this negative number. We have more money than we want to spend. So this number is positive. All right, well, let's go ahead and turn this into a fraction. And convert this to an improper. 1 4 5 6 7 over 4. And we know that the denominators need to be the same, but they're not. So we can multiply this side by 4 to get the denominators to be the same. So this rewritten would be 2 times 4 is 8 over 4 minus, sorry, that's a negative, right? Minus 7 over 4. So let's look carefully at this. Remember, we're subtracting 7/4. We have a negative and we're subtracting 7 more. So really what we're doing is instead of subtracting, we're adding a negative. Okay? Remember this scenario. Well, 4 minus 2 is really the same as 4 plus negative 2. Okay? And our denominators are going to stay the same. They are 4. So now we have a negative 8 and a negative 7. Well, those are both price tags. We apparently forgot our wallet when we went to the store, so this is just negative 15. And that is an improper. So let's go ahead and change it to a mixed number for fun. 4 times 4 would be 16. So we know 3 4s make it 12. That gives us 3 left over and 4. And because this is a negative divided by a positive, we know our answer is negative 3 and 3/4. All right, last one. So let's go ahead and look at our denominators. They're not the same. Will the small fit into the big evenly? It won't. So we're going to multiply these together. So this 3 is being multiplied by this 8. This 8 is being multiplied by this 3. We're going to do the same to the tops. And we're going to go ahead and rewrite the two fractions. So this is 2 times 8, which is 16. And 3 times 8 is 24. I don't see any negative symbols, but here's a negative right here. I'm going to put that there. 3 times 8 is 24. I know our answer is going to have a denominator of 24. And this is 3 times negative 3, which would be negative 9. Let you look at that for a minute. This would be the same as if I wrote 16 minus negative 9. Because that's really what we're doing here. 16 minus negative 9. Well, those are together, so we can plus those out. So we have 16 plus 9. Well, that just equals 25. And we can convert that into a mixed number. 24 goes into 25 once, with 1 left over and a denominator of 24. And that is our last and final answer. So I hope this has been helpful for you, and if you have any questions, please feel free to reach out to me either by my office number or through the Google Classroom. Thanks and have a pleasant day.